Hi there, welcome back to the channel. Now, a student requested a video on projectile motion, so I'm going to quickly take us through projectile motion. We're going to be seeing derivations and possibly how to solve rather questions. Okay, I'm going to give us a question and then you see how to use your formulas to resolve it. Okay, so in order to understand projectile motion, which is basically motion in two dimensions, you must first understand motion in one dimension that we call unidimensional motion or translational motion. Now with that unidimensional motion, we have motion of a body along a single plane. So the body could be moving from the negative y-axis to the positive y-axis, or positive x-axis or negative x-axis to the positive x-axis. So in as much as the body did not move away from one plane, we say that the body is experiencing a unidimensional motion or motion in one dimension. Okay, so in that case we were able to have seen that I've done that video before, so I'll link it in the description so that you see how we generated the following equations of motion, which include we call them suivants, right? Or something like that, yes, suivants. So S equal to U plus V over 2 multiplied by T. This is the first equation. Then we saw V equal to U plus AT. You also saw that S equal to UT plus 1 over 2 AT squared, and V squared equal U squared plus 2AS. Now, if you don't know how to derive all these formulas, I'll link the video in the description where I have derived these formulas before, so I will not be doing that today because we use this for unidimensional motion. Actually, we are going to be using this as our, would I say, precursor equations. The equations we'll be using that we'll find handy in deriving projectile motion equations. Okay, so now what's a projectile first? Now a projectile is basically a body that is projected, projected, that is, launched, okay, in two dimensions. So when, for example, if I throw this body, now if I throw it from here, let's say it was a football. So if this is a football and I kick the ball such that it moves from here to this place, you are going to say that the body, this ball has moved in two dimensions. Okay, why? Because it is rising as it is also running and is going in this direction in a parabolic movement. Okay, so I'm going to show us by equation also how I'm going to be proving how that the motion of the projectile is actually along a parabola. Okay, it's parabolic. Okay, so which means that we're going to derive a quadratic equation for it. All right, but my point is this, that path that it takes is called the trajectory of the projectile. The trajectory of the projectile is the path that it takes, okay, to cover its entire motion in its entire course of movement. Okay, now how do we analyze the projectile motion in movement? Now in the two-dimensional plane, like I just said, the body is going to move like this and then come down like this. So you're going to see that it is moving along a parabola, right? So what that means is that the body is not exactly moving upward and is not just moving rightwards. It is doing both at the same time. Okay, so in order to analyze the motion of the body, we can only analyze with respect to the two dimensions or the two paths within which it moves. Okay, it's moving in both the y-axis and both the x-axis. So meaning that the vectorial quantity of this motion of this projectile body is going to be examined in both the y direction and the x direction. I don't know if you understand what I mean. So for example, the acceleration of this body is in the vertical direction, right? The speed of this body also, which is also a vector, is also in the tangent, is along the tangent to any particular point. So for example, if I want to get the velocity of the body at this point, then it is going to be the tangent the direction of the velocity is going to be along the direction of the tangent at that point. The tangent at this point. Now, even at this point, where is the peak of the motion? So that is where v is going to be 0. I'm going to talk about that soon. So these are our velocity vector. Now, the initial velocity which the body was launched with, or which it started with. Now, thank you, sir. No. All right, sir. So the initial velocity here, we call it u, okay? So this initial velocity u, which is a vector, is going to be along this path from the beginning here. Does that make sense? Okay, and it's changing per time, right? It's changing per time, which means that there is acceleration in this y-axis. I'm going to also explain what that means, so just stick with me. Now you see that this body is moving in both y and x direction at the same time. So it's going to have a y component, a y component, which we'll call u sub y. So that will be the speed along the y-axis. And it's going to have a u sub x, which is going to be the speed along the x-axis. Now keep in mind that since this body was launched in this direction, it means that there is an angle of its projection. The angle of projection here is going to be this angle theta, which is away from the x-axis at which it is launched. Actually, there are two angles of projection if you want to see. We can either look at it from here or this direction, okay? But we usually just operate with this one that is inside the parabola, okay? All right, so now let's first talk about the values of this u sub y. Now in u sub y, if you are resolving this u to this component, our u sub y therefore will be equal to what? We are opening this angle. When you are opening an angle, I said it's what? Sine theta. So that will be u sine theta. You'll be opening this angle, right? But we are resolving u to get the x component of our velocity, initial velocity, we'll be resolving u to this axis, right? To the x-axis. That means we are closing, and cos is closed, right? That's why they began with cc, or they begin with cc, okay? All right. Although I've proven that before in another video, so, but just for the purpose of quick understanding, just know when you are closing an angle cos theta, when you're opening an angle sine theta. Okay, now here's the deal. Now you see that these are the x and y components of our velocity vector. Now listen, by the time the body along its course of motion at a particular point here, for example, this body is going to have a particular v sub y and a particular v sub x. What does v sub y mean? The velocity at time t, okay? So the velocity at time t at a particular time is going to be given as what? But this velocity, keep in mind that this is the velocity along the y-axis and this is the velocity along the x-axis. I mean, this one is the velocity along the x-axis. Okay. Now, what will be the velocity along the y-axis at a particular time t? At a particular time t, we know that that body is going to have, from this equation here, let's call this 1, let's call this 2, let's call this 3, let's call this 4. All right, so you know that at a particular time t, that this body is going to be engaging v sub y in a motion of u sub y plus here at. Now acceleration, let's talk about acceleration before we talk about this. Now let's talk about acceleration along the y-axis and acceleration along the x-axis. Now along the y-axis, this body is accelerating, but along the x-axis, the body is not accelerating. Why? Because if it starts with a particular velocity here, it's going to go up with that velocity, which will be reducing constantly as the body is moving upward, and at a particular point just above the ground level, at a particular point above the ground level, is going to stop momentarily before it drops. Watch this, just watch this, my marker. So I'm going to throw it up, and then you're going to notice it stop momentarily, just like from for some microseconds or milliseconds, whatever the calculation is. So you see this body. Now before it began, all right, let's continue. I noticed my microphone stopped working, so I'm going to continue from here. I said that, so you will notice that the body stopped momentarily and then began to come down after it had gotten to velocity 0, because the velocity began to increase. By the way, please subscribe to the channel. I have actually shot this video to the point of beginning to derive before checking that my microphone was off. So sometimes those sacrifices, so that it will not go in vain, and just try to help the channel by subscribing. I know some of you honestly forget, so please subscribe to the channel if you are gaining value, of course. So please, right. So like I was saying, I said that the motion of the body is such that it will go with the maximum velocity from the ground or from where it is launched, and the velocity as it goes up will decrease up until it gets to 0, and then after which it will begin to what? Come down. Then as it's coming down, the velocity what? Will be increasing again, so that just before it touches the ground, it's going to attain a maximum velocity again, right? So the body attains the maximum velocity by the time it what? Touches the ground. And at that time, A sub y is going to be what? When it's coming down, A sub y acceleration is going to be what? The body will be free falling, or free falling, that is, to be falling under gravity. So when the body falls under gravity, it means that it's accelerating as what? With acceleration due to gravity. When it is going up though, the acceleration due to gravity is what? Negative g. Does that make sense? Because it's acting against gravity. Gravity is pushing down, the body is accelerating with gravity upwards. Does that make sense? All right, so that's why A is going to what? Minus g. Then this guy, acceleration on the x-axis, is going to be that is going to be such that if the motion, the velocity of this body rather, is changing on the x-axis, then this guy is going to have a value. But as you can see here, the velocity with which it started here was maximum, and the velocity that it ended here is maximum. So it means that the body did not change velocity across the x-axis. So because of that, the A sub x is going to be what? 0. The velocity did not change on the x-axis at all. So velocity acceleration here is going to be what? 0. Okay? So if this be the case, then I can therefore say that this, my acceleration here, using this equation, A is going to be what? Minus gt. Okay? So if I bring this guy here, u sub y is going to be what? U sine theta. So I have u sine of theta, then minus gt. So let's just call this equation 1. Okay? Then v sub x is going to be what? Since the velocity did not change at all on the x-axis, then v sub x, which is velocity at a particular point in time here, velocity at a particular point in time here, is going to be what? U sub x, because it did not change at all. And what is u sub x? That is u cosine of theta. So ux is u cos theta. So let's call this equation 2. All right. I did not name these as equations because they are just notations that represent u sub y and u sub x. Okay. All right. Now, I've already started to talk about the vectorial analysis here, but I've also mentioned about the horizontal distance covered. So the distance covered by this body, what I'm just trying to do is, let's first analyze all the parameters that we use in discussing about the motion of the body. So we talked about the velocity, we talked about the acceleration. How about the distance it covers? The distance that this body will cover, the horizontal distance, remember, distance is going to be what? Velocity or speed times time, right? So, and what's our velocity here? On the x-axis is u sub x, right? That's the horizontal distance it covers. U sub x times what? T, okay? So x is going to be what? What's u sub x? U cos theta. So we have u cos theta multiplied by time. So this is going to be our horizontal distance. All right. Now, here is the catch. Here is the catch. Let's now determine the other thing we have to now talk about is the vector. So you see this velocity here is the vector. If I analyze by vectorial analysis, I know that here I have v sub y, here I have v sub x, and then the resultant of the motion here is going to using triangular law of vector. If this were moving in this direction and these were moving in this direction, then so that we draw it such that we have from the head of one to the tail of the other, then it means that this guy is going to go in this direction, okay? So that this will be v sub x, and this will be what? V sub y, okay? Using triangular law of vectors. I've already made a video on this. Now, so this is the vector. So if we want to find this vector, we're going to use Pythagoras theorem. That will be hypotenuse squared is equal to opposite any side squared plus what? adjacent squared. All right, so that is another equation you have to know. Now, what are the things that we have to find when it comes to this? Now, number one is time of flight, okay? Now, there is time of flight and there is total time of flight. Time of flight is the time the body spends on air. Now, the time of flight is divided into two. The first time of flight is the time from the beginning of the motion to where it goes to its highest height, okay, its maximum height. Then the second time of flight is going to be the time from its maximum height back to its point of start, right? So this is point of starting, and from here to here is going to be a particular t, and from here to here is going to be a particular t. But one peculiar thing with projectile motion is that the time taken to reach the maximum height is going to be the time taken to go back to the point of starting, provided that the motion is not inclined. So after this video, the next video I'll make is projectile on an inclined plane, on an incline. The formulas are quite different, so you make sure to see that video as well. So my point is this. So the time of flight is the time that we could analyze it in two ways. First, we could find the time it took to get to the maximum height. Now, I can use this equation, for example. However, I'm going to use these two equations so that you can see how to do that. So V is going to be U plus AT according to that equation, right? But you know that at maximum height, we are going to be having V sub Y, right? Okay, at a particular time V time T, V sub Y is going to be 0 at maximum height, right? Just listen, I want to first analyze the time taken to get to the maximum height. V sub Y, velocity, final velocity at that maximum height is going to be 0. Why? It's going to be 0 because at that point, it's going to stop momentarily before it begins to fall, right? We already said that. Now, we now know that 0 therefore will be equal to U here. It's going to be U sub Y. And what is UY? That is U sine theta. Then minus, now because it's horizontal, it's going up, right? So minus GT. So whether it's positive or negative G, is the G there is in terms of, it's qualitative, okay? So it's not bad, it's not good, okay? All right, so this guy comes in and we have GT equals U sine theta. Then the time of flight is going to be equal to, with the variable size by G, then T equal to what? U sine theta. This is the formula for time of flight, but not total time of flight. Now, what will be the formula for total time of flight? Because this Baba is going to move into, there are two divisions of the motion, two points of symmetry, right? One point of, there's symmetry in the motion from here, right? So this motion here, motion in the first half of the parabola is equal to motion in the second half of the parabola. So which means that it's going to cover that distance, two times, right? There will be 2 times. So we'll just say 2 times t, or big T, which is total time of flight, is going to be what? 2 times of t, which is 2 times of U sine theta over G. In case you don't understand this, here's another way to prove that. You know that S is given as UT plus 1 over 2 AT squared. Okay, so in this case, it's going to be what? The distance covered in the vertical direction, right? So if that is the case, then we have that no, we want to talk about total time of flight. Total time of flight is the time taken to get from here to here. So I want to use this equation now. For this equation, for this equation, I used it based on what? Maximum height gotten to, right? I'm going to talk about maximum height soon, okay? But in this second equation that I want to use to derive this same formula, I want you to be able to use both methods, okay? I want to define it with respect to, say, if the body were to move from here to here, if it moved from here to this point, what is the vertical distance covered? The vertical distance covered is going to be 0, right? The vertical distance covered. That is, it did not cover a vertical distance, okay? And we are analyzing, because it came from here to this place. I don't know if you understand what I'm saying. From here to here is the same horizontal plane. So vertical distance is 0. So time of flight. So the time is spent on flying is what we want to analyze. But here is not flying at all. So vertical distance is what? 0. Then U here is going to be U sub Y times T. Now, because it's time spent on flying, we can say that this is minus gt squared. I mean, minus half gt squared. It could be positive also. It doesn't really affect the value. There's no negative time, there's no negative time per se. Is that okay? So my point now is that we can bring this guy here and then we have half gt squared is equal to u sub yt. Now, you know that u sub y is what here now? U sub y is u sine theta. So we have 1 over 2, or let's just say gt squared over 2 is equal to u sine theta multiplied by t. Okay, so t can take care of one of the t's, right? So we have gt over 2 is equal to u sine theta. By the time you cross multiply, you have that gt equal to what? 2u sine theta. Yes, it's already looking like it. Do you see that? So divide both sides by g. So we have t equal to what? 2u sine theta over g. Okay? All right. So this is another way to derive the total time of flight. Now the next formula you'll be asked to derive, or that you might need to know, is our formula for maximum height. Okay? So let me just clean this place. Formula for maximum height. Now, what is the maximum height reached? The maximum height reached, the formula we can use to derive that is this formula here. Our fourth formula, maximum height. Now, this fourth formula says that v squared is equal to u squared plus 2as. Remember also, I might always remember rather, that v sub y, because it's maximum height, the final velocity is going to be 0, right, at maximum height. So we have that v sub y is equal to 0. So this place is going to be 0 equal to, the initial velocity is going to be what? U sub y, uy all squared. Now minus, because it's going up, minus negative g, minus 2g. Now s here is going to be our maximum height. Does that make sense? Because s is distance, right? Now, but this time we are covering vertical distance. All right? So this guy comes here and we have 2g h max is equal to u sub y all squared. Now what's uy? U sine theta. So we have that h max will be equal to, by the time you divide both sides by 2g, u sine theta all squared over 2g. So you can write this in the standard way by saying h max is going to be what? U squared sine squared theta over 2g. Does that make sense? So this is the formula for maximum height. That's the formula for maximum height. Okay? Now, then someone has asked me about using, let me first derive the last equation. Let me derive the last equation first. Now the last equation you will need, not the last. There are many other equations, because when we begin to also talk about motion on an incline, okay, the projectile motion on an incline, that one will be quite different, okay? So look at this now. What if I want to talk about the maximum range? The maximum range, that is the maximum horizontal distance. Remember, this is the formula we use for horizontal distance. So recall that we said that the horizontal distance is given by, horizontal distance x is given by u cosine of t. Okay? Now u cos t is going to be equal to, what's our formula for time? Okay? Formula for time is what? 2u, what's formula for time? For time t. Formula for time t. Let's quickly generate that again. You know that t, time of flight, is going to be u sine theta over g. Okay. Yes, u sine theta over g. So we can bring that in 2u sine theta over g, sorry. Horizontal range, total time of flight, okay? Horizontal range, because total time of flight, total time spent in flying, it's because I cleaned it, I thought I put it somewhere. We are supposed to be putting our formula somewhere. So whenever you're deriving like that, you're keeping your formula somewhere. You can be keeping it in your pocket or keeping it in your safe. So here we have t. Recall that t also is equal to what? 2u sine theta over g. So if that be the case, then x will be equal to what? U cos, sorry, this is u cos theta t, u cos theta t. All right. So I'm checking my microphone so it doesn't go off again. We had already got into time of flight before I discovered the other time. All right, so multiplied by 2u sine theta over g, okay? Now, so our x will be equal to what? 2u squared cos theta sine theta all over g, okay? Recall from trigonometric identity. If you don't know trig identity, I've told you, you can ask me on WhatsApp, okay, or you just put in the comment section. See, I want you to engage in the comment section as well, please. And remember to subscribe, okay? If you can remind me to release a video on it. Is that okay? The video will be explicit and very explanatory. Now recall, and that is how we generate all these formulas. Trig functions, trig identities, how we use it to generate all the formulas. So, but what I wanted to say is that recall that there's a trig identity that says that 2 cos theta sine theta is the same as sine of 2 theta. Yes, we can prove this. So if that be the case, then we know that x will be equal to 2, so 2 cos theta sine theta is equal to what? Sine 2 theta. So we have u squared sine 2 theta over g. So this is going to be the formula for maximum range. Okay. Now the range is actually maximum. You can only get the maximum range where theta is projected at 45 degrees. So that if theta is projected at 45 degrees, by the time you do that, 2 theta is going to what? 90 degrees. And sine of 2 theta will be equal to what? 1. So at that time, at maximum range, you have that x equal to what? U squared over g. U squared over g. So, and that is the formula for maximum range. Now, what if we now wanted to find the direction of our velocity vector? We want to find the direction of velocity vector. I don't think we need this anymore. So, if we want to find the direction of our velocity vector, how do we do that? Now, you know that our velocity vector, we had a vector that looked like this, a vector diagram that looked like this, right? And from the tail of this, it should go like this, right? We're going to draw it head to tail, then head. So this is the vector. So if you want to find this, remember that you are going to be using tan theta from vector, right? So tan theta is going to be what? Opposite over adjacent. What's our opposite here? That will be v sub y is usually our opposite over v sub x. Vertical component over horizontal component. So you have, what's our v sub y? Basically, that's it, right? Okay. What's our v sub y? Formula for v sub y: u sine theta minus gt over theta equals this. V sub x is what? U cos theta. Okay, so this is another formula. This is the formula for finding the direction of our velocity vector. By the time you want to find it, you say theta equal to tan inverse of this, right? Okay, tangent inverse of that, right? So now let's go on to solving the question. So for example, if the question says that a body is projected with an initial velocity 40 meters per second at an angle of projection is, let's say, 30 degrees. I just want to use a sweet angle, okay? It now says find the initial velocity, the horizontal component of the initial velocity. Horizontal component of the initial velocity, that's what? U sub x. How do you do that? You just say u cos horizontal component, u sub x. Yes, u cos theta, right? So u sub x, horizontal component is what? 40 times cosine of 30. Okay, and what is cos 30? Cos 30 will be 40 times root 3 over 2. By the time you do this, u sub x will be equal to what? 20 root 3. So, and that will be the horizontal component of the velocity. What will be the vertical component? Simply say v sub y equal to u sine theta. But now, what if the question now says that find the vertical component, find the vertical component Find the vertical component at time t equals 1.2 meter or 1.2 seconds. Oh no, let's use a sweet one, 5 seconds. And it says you find the vertical component at time t equal to 5 seconds. Okay? How do you do that? Now you know that at time t we have v sub y, the vertical component, right? It's going to be what? U sine theta minus gt. Okay? So v sub y will now be equal to what? U, what's our initial velocity? 40. Sine 30 minus, what is g? Now g is anytime you are giving g, you should use 9. If you are not given, rather, always use 9.8. If you are not given, so use 9.8 multiplied by, what's the time? 5 seconds. 5. Okay? I like 10. Let's use 10. Let's change it to 10 seconds. Okay, let's use 5. Let's use 5. So you know that v sub y therefore will be equal to what? 40 times sine theta. What is sine 30? Half. Half of 40, 20 minus 9.8 times 5 will be 98 divided by 10. That's divided by 2. That's 49. So minus, no, sorry, 98. Okay? Divided by 2 now. That's 4.9, sorry. No, not 4.9. This times 5, that's 49. Yes, that's 49. Okay? So by the time you do this, our v sub y is going to be minus 29 meters per second. Okay, so according to my question, this is going to be what you will get as your vertical component of the velocity at a particular point. That. Now, if you are told to find the angle between them, you simply say that the angle tan theta between them is going to be what? U sine theta minus gt over u cos theta. And we've gotten this, right? This gave us minus 29 over. But actually, whenever you have a negative here, it's going to be the absolute value that you will take. Okay? So we are taking the absolute value, that will be 29. And u cos theta, what did u cos theta give us? I already solved it. Wow, that's always great. So we have 20 root 3. So by the time you do this, you get your answer tan theta. So your theta, angle theta equal to the tan inverse of 29 over 20 root 3. And that will be your answer. All right. In the next video, we're going to see motion of body on an inclined plane, of a projectile on an inclined plane. Do well to subscribe to the channel and click the bell notification to get notified whenever I drop a new video. God bless you.